All right, good morning, everybody. Today, we're going to be talking about proportional relationships, okay? And we've already been talking about proportional relationships, okay? But we're going to look at them in a different way, okay? So, we've talked about a graph, we've talked about tables, okay? We've talked about proportionality, okay? A little thing different, we've talked about the equation a little bit, and that's y is equal to kx, all right? And then we're going to talk about a verbal description, okay? All right, so we'll go ahead and get started here, all right? Now, everybody should have these papers. If you don't, you can come to the school and get them, like I've said earlier, okay? Or you can print them out yourself, all right? So, proportional relationships represent a constant rate of change. Okay, so they represent a constant rate of change. So when we're talking about proportional relationships, we're talking about things that have the same unit rate. Okay, and that's also called, or can be, the constant of proportionality. Okay? The constant of proportionality. All right, so two things will be true about a graph that is proportional. Okay? The graph will be a straight line. All right, we talked about this yesterday. Okay, another word we can use for that, I'm going to put it in parentheses, is linear. Okay, if it's linear. So, it's got to be these two things. Okay, it has to be a straight line. Okay, and the graph has to pass through the origin. Okay, has to be a straight line and pass through the origin. Okay, and if you remember, this, where your x and y axis meet, right here at this little point, that's your origin, and that will be 0, 0. Okay? Okay. Now, in a table, we want to check for equivalent ratios. Okay? And what this is saying is, in other words, a proportional table, the ratio of x or y over x will always be constant. All right? Which means the same. All right? We've already talked about this. All right? So, just for this example here, okay, my miles or my y, x, okay, is x is my hours. All right. So, and we'll see this. I don't know if we'll see it in this one, but we've seen it. Okay. With this extra little column in here, y over x. Okay. All right. And y over x is the same thing as our unit rate and constant proportionality. Okay. Now, let's talk about this first problem right here. Okay. The number of miles a white-tailed deer travels is shown in the table below. Complete the missing information and answer the question. Okay. So, we have our table here, and that's what we need to start with in this case. Okay, this is what we need to start with, because this is really the only thing we have any information on. Okay, so what we need to do is we need to figure out our y over our x. Okay, we're going to see if these two are the same. If they are the same, then it's going to be proportional. All right, and then we can figure out the rest of this. Okay, so remember it's y, 84 divided by 3. Okay, that gives us 28. All right, let's see if this one does. 196 divided by 7. That also gives us 28. Okay. Now, if we remember this equation, this is the one we're going to use. Okay? Y is equal to kx. All right? Now, we have to remember that k is the same thing as y divided by x. So, y divided by x, well, this is basically, that's your k number. Okay? That's your k number. So now that I've figured out what k is, in my equation down here, I'm going to put that number in for k. Okay? So if you look, I just replaced k with 28. Okay? That's what that represents. So the equation that I will use is y is equal to 28k. All right? Because this is the unit rate. This is how much it goes up by each time. Okay? So I'm going to go back to my table. Okay? Now, this all should be 28 now. Okay? So I can go ahead and fill this little column in that I made. Okay? It's proportional. Now, to figure out my miles, okay, to figure out my miles, I'm going to do y is equal to, because this is my y, that's what I want to find, 28, and I'm going to times it whatever my x is. So in this case, this first one, it's 1. So times it by 1. 28 times 1 is 28. Okay, the next one, y is equal to 28. All right, my 28 doesn't change. What happens to my x? Well, what is x now? It's 2, so I'm going to times it by 2. Okay, and I should get 56. Okay, we already know this one, so I can skip it. Let's go down here to 4 hours. So in 4 hours, I want to know how far that deer ran. So I'm going to take y, because this is how far he ran, is equal to 28, okay, my equation, 28, and I'm going to times it by 4. Okay, and 28 times 4 is 102. Okay, move down to the next one. Y is equal to 28 times 5. Okay, because after 5 hours, if he runs 28 miles per hour, then this will help me. All I got to do is multiply. All right, so 28 times 5 is 140. Okay. 28 times 6 should give me 168. I already have this 7 here, 7 hours. Let's go down to the 8. 28 times 8, okay, is 224. All right, and then the last one, 28 times 9, should give me 252. Okay, so now I have my table completed. So in 1 hour, the deer ran 28 miles. All right. In 4 hours, the deer ran 112 miles, or could. Okay, if he runs 28 miles an hour. All right. So let's work on the graph. Okay, so I have my x. Here's my x-axis. Okay, so I need to put hours down here. Okay, because that's what X represents, is the number of hours. And I'm going to fill in just with these numbers. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. All right. My y-axis, remember, y goes up and down, all right, vertical, and that's my miles. Okay, because that's what y represents, is my miles. Okay, so these need to go up the same every time. Each line needs to represent the same amount going up each time. So if I just follow my table, it goes up 28. It goes up 28 again, so that's 56. Okay, so I'm just going to put these numbers in. Okay. Now, I'm just writing ordered pair down. Okay. All right, so the ordered pair for this first one, remember your ordered pair is XY. So my X and then my Y is 28. Okay. Next one is 256. Okay. 384. Okay. If you want to go on and write all those down, you can. All right. So let's look at the first one. 128. So I got to go over 1 and then up 28. Okay. And that's where I'm going to put a dot. Next one is 256. The next one, 384. Next one, 112. Next one, 140. The next one, 6 and 168. All right, 7, 196. 8, 224, 9, 252. Okay. Now, I don't have a ruler, so I'm going to make this line as straight as I can, okay? Remember to put your little arrow at the end, okay? Now, so I finished my graph, okay? That looks like a straight line to me, and it looks like it does go through the origin down there, okay? So in this proportionality box, okay, we are going to say why it is proportional, okay? So you should have 3 little points down here. Okay? 3 little points. All right, and it doesn't matter which one goes first, okay, but we're going to talk about the table first. All right? From the table, we know that this relationship is proportional. How do we know that this is proportional? Well, we know it is proportional because the K value, okay, which is y over x, is 28, okay? So we have a constant rate of 28, all right, and miles per hour. Okay? Constant rate of 28 miles per hour. Okay, so you're going to, under proportionality, one of these points is going to be represented from the table. Okay, so you're going to look at the table and you're going to tell me if it's a constant rate or not. All right, and we know because we took y divided by x on all of those. All right, these next two, we're going to look at the graph. Okay, I'm going to kind of go over here to this one. Look at graph. Okay, so what did we say about the graph? Well, we talked about it up here. It needs to be a straight line and go through the origin. Okay, is this graph a straight line? Yes. So we say straight line, or we can just write linear. Okay, and does it go through the origin? Yes. Goes through the origin. Okay? Okay. Now for your verbal description. All we're doing is we're explaining maybe what this table says. Okay? And what are we talking about? We're talking about a white-tailed deer. Okay? So, a white-tailed deer travels at a constant rate of, well, 28, and what's our x and y? Okay, miles per hour. We can just do mph. Okay? All right. Okay, this is what we're going to skip a page. Okay, so we're going to skip this page, which is the next page in your packet. We're going to skip it. Okay, we're going to flip over to this page. Okay, and this is talking about hours rented and total cost. Okay, so I only got about 5 minutes left on the video, so I'm going to try to walk you through this, okay, as quick as I can. So what we need to do, let's make our other column in here. Okay, and this is y over x. So just like I did before, we need to figure out y over x. All right, so our total cost is our y, hours rented is x. Okay, so let's do that. So we have 24 over 2. Well, 24 divided by 2 is 12. All right, 84 divided by 7, that's 12. So all these should be 12. Okay? Now, if all those are 12, then our equation will be y, and remember this is our k value, is equal to 12, because that's where this goes, x. Okay? Now, I want you to fill in the rest of the total cost using this equation. So you would do 12 times 0. Well, 12 times 0 is 0. Okay? 12 times 1 will give you this number. 12 times 3 gives you your y, your total cost. 12 times 4 is your total cost, and you just keep going from there. Okay? Now, you need to graph on your paper. Okay, so you can look at your graph. All right, and your x is hours rented. All right, and your y is total cost. Okay? Remember, there's 3 bullet points in here. So you need to fill those out. just like we did on the last one, okay? And I'll probably ask you a question about it, all right? And I will be asking you questions about some of the numbers in here, okay? So let's look at these last three questions pretty quickly. All right, the bike rental company has determined that they will charge based on the nearest half hour. Okay, so if Michael rented a bike for 5.5 hours, how much would that cost? Well, if we're talking about the nearest half hour, we're going to take this 5.5 and we're going to round it up to 6 hours. Okay, so we want to find out how much he rides in 6 hours. All right, so we use this equation. All right, if we've already filled in our table, there's 6 hours right here. All right, and you can get that number for number one right there. Okay. Number two, what does the 0.784 represent in this situation? Well, remember this is X and this is Y. So X is your hours rented and your Y is your total cost. Okay, so tell me what those represent. All right, number three. If a customer has $50 to spend, how many hours can they rent a bike? So this is your total cost. So you need to do this equation and put 50 on this side. Okay? And I've showed you how to finish this right here. All right? Divide 12 by each side and that'll give you how many hours. Okay? There'll be about 5 questions for this. Okay? If you need any help, make sure you're on the Google Meet today. Okay?